Okay, in this video I'm going to talk about equilibrium and how you can determine the direction to which the equilibrium shifts based on the Q value, and then we're going to solve an ice table for concentration of other components in equilibrium. So the first thing we notice is that the following equilibrium takes place, where we have two NOs plus two hydrogens is in equilibrium with a nitrogen and two waters. The initial concentrations of all the reactants are here: 10 molar NO, 8 molar hydrogen, half molar nitrogen, 4 molar water. The first question we want to know is to which direction will the equilibrium shift? So we need to solve for Q. Q is an expression in which at equilibrium Q equals K. So the Q expression is taken at any point in time with the given values of the components, the concentration of the components. So the Q value for this is going to be the concentration of nitrogen, products over reactants to their orders. So nitrogen has no coefficient, and so it's assumed to have a coefficient of 1, so it's nitrogen to the first power times the concentration of water squared, because the coefficient is 2, divided by the reactants, concentration of NO squared times concentration of hydrogen squared. So if we're at equilibrium, then our Q is going to be equal to K. Our K is 650. So let's plug in those values and see what our Q expression is. Nitrogen has a concentration of half molar times water has a concentration of 4 molar, and it's squared. NO has a concentration of 10 molar, that's going to be squared, times the concentration of hydrogen, which is 8, also squared. That gives us a Q expression of 0.5 times 4 squared divided by 10 squared times 8 squared, 0.00125. Now let's evaluate our Q compared to K. Q in this case is significantly less than K. When Q is less than K, it means this value, our Q value, is too small. We need to make our Q value bigger in order that it reaches equilibrium. So we need to make this number, 0.0125, bigger to get to 650. In order to get bigger, we need our numerator here to be bigger. Our numerator here is the products. So in this case, our equilibrium is going to shift right to increase the concentration of the products. So let's figure out this ice table to determine what our equilibrium concentrations are. So I'm going to rewrite our equilibrium expression here. 2NO plus 2 hydrogens is in equilibrium with nitrogen and 2 waters. Our ice table is all set up, so our initial value of the NO is given to us here. Our initial value of NO is 10 molar. Our initial value of hydrogen is given here, 8 molar. Nitrogen is half molar. Water is 4. The change. We know our equilibrium is going to shift right because Q is less than K. We're going to increase our products. They get plus signs. We are going to decrease our reactants. They get minus signs. We're going to decrease by the amount of the coefficient. That comes into play again. So our change here for the NO is minus 2x. Change for hydrogen is also 2x. Our nitrogen is going to increase by x. And our water is going to increase by 2x. So, at equilibrium, the concentration of NO is going to be 10 minus 2x, 8 minus 2x, half plus x. Oh, just wait a second here. not half times. No, no, no. Half plus. 4 plus 2x. Okay? Now the next piece of data, before we go solving for x and worrying about what assumptions we're going to make and so forth, keep in mind that we know this piece of information. The NO concentration at equilibrium is 2.4 molar. So that means at equilibrium, this expression here is equal to 2.4. So we can set up an equation, 10 minus 2x equals 2.4. Now we can just solve for x. In solving for x, you subtract 2.4 from both sides, add 2x to both sides. So we get 10 minus 2.4, 7.6 equals 2x. Divide both sides by 2. X equals 3.8. So now that we know what our x value is, we can plug it in to every one of these x's here to get the equilibrium concentration for those reagents. Right? So, at equilibrium, hydrogen will be equal to 8 minus 2x. Can plug in for x. 8 minus 2 times 3.8 gives us an equilibrium concentration of hydrogen of 0.4 molar. And that makes sense, remember. We wanted our equilibrium to shift to the right to give us more products. It should decrease the amount of reactants that we have. The equilibrium concentration of nitrogen is 0.5 plus x. Gives us an equilibrium concentration of 4.3 molar. And finally, our equilibrium concentration of water is 4 plus 2x. 4 plus 2 times 3.8 gives us an equilibrium concentration of 11.6 molar. I hope that helps.